So 2 is a little weird because it's not really something we talked about, but it's partially what we talked about. So when you're looking at the domain, you're looking left to right. So if you were drawing in ceilings, the highest point, the floor, the lowest point, or walls, the furthest point to the left and right, this has arrows. So we don't really have walls. It's going to keep going left and right forever and ever in both directions. Except there's a point that's open. So it does keep going left. It does keep going right. But it's not all real numbers because there's a point missing. So we would write this in a weird way. It would start at negative infinity. It would go to, I think this time by 2s, so 6. But because this is open, it would not be included. And then we're going to do the annotation you haven't really seen, but you won't really see again until algebra 2. Put this U, it means and also 6 to infinity. So it starts at negative infinity, it goes all the way to 6, then there's like a hole there where it's not included, and then it keeps going from 6 to infinity. So it's like everywhere except at 6. Questions on that one? Many of you that I saw that did this, did the first one, did get the right answer. It should be all real numbers, negative infinity to infinity. To those of you that got that, good job. So today's lesson is going to be about parent functions, and I'm going to explain what that means, and different transformations and how we describe them and things like that. So first, before we do anything, reset your calculator, 2nd plus 712. And the very first thing we're going to do is graph this equation, this function. It should look very familiar because it is a quadratic, so it's going to be graphed the same way we were graphing before. But go ahead and in your y equals, put in x squared. And then we could go to the graph, but we're just going to go to the table for this just to get values. So second graph. Just as we were doing last unit, find where your y values repeat and then find the middle, which would be at 0, 0. So we're going to plot that point. And then plot at least 5 points. So we have negative 1, 1 and 1, 1. Negative 2, 4 and positive 2, 4. And the other ones won't be able to be graphed on this, so just those 5 work. So this is what's called the parent function. If nothing happens to it, there's nothing added to it, nothing else with the function, this is what it will look like every single time. So we're going to do things to it and see what happens compared to the original. So in our y equals, we're going to put plus 2, and we're going to see what happens and compare to the original. So go back to your y equals. At the end, put plus 2. And then graph it. What happened compared to the original, the parent function? What changed? Say it again. Not in this case. It went up 2. So that would be the change. That's what we would say change. It went up 2, or it moved up 2. So that's how it physically changed. But there's a specific rule. The rules are what we actually need to remember. but knowing how it changed, looking at it also is good information. So this would be a vertical shift up by 2, or up 2. So anytime we write the rule, we have to be very specific. Is it a vertical or horizontal type of transformation? What type of transformation it is, so the shift, what direction it's going up, and then by how much, too. So if the plus 2 moved it up 2, what do we think this one's going to do? Down 2. Yeah. Now let's graph it just to make sure. Ooh. And it did move down 2 from the original. So then the rule will be very similar to the first one, except now down 2. So now we're going to do this next one and see what happens. So go ahead and put this into your calculator and see what happens, what changes. Make sure you're using your parentheses. Put the square on the outside. And then graph it. Compared to the original, what happened? Someone said it. Emma. It moved left too. So this is like going back to when we were talking about the vertex. What it does on the inside does the opposite. You think it's going to move to the right, but it actually moves to the left. So this would be a horizontal shift left 2. So if that one moved left, what do we think the next one's going to do?
Right.
It's going to move right. I'm going to graph it just so you see that is what happened. But it did move to the right. So this would be a horizontal shift right. And once you have that written down, go ahead and put the next one in your calculator and see what changes, what happens with that one. What does it look like happened? It does kind of look that way, so let's look at the values. It did get skinnier. So it started at the same place, but instead of -1, 1, it went to 2. Instead of -2, 4, it went to 8. So it was like all your y values got multiplied by 2. So that's really, yes, it got skinnier, and then we'll talk about the rule. Skinnier, narrower, either or. So the rule for that is a vertical stretch. It's stretching towards the y-axis, so it's getting narrower as it gets closer to the y-axis. You could say vertical stretch by 2 or vertical stretch by a factor of 2, either or. then we can probably assume that this would be the opposite, but let's see it first. So go ahead and put this one in your calculator. What did that one do? Got wider. So that would be a vertical, and I did not spell it right, vertical compression by 1/2. So where a vertical stretch is stretching towards the y-axis, a vertical compression is shrinking away from the y-axis. So it's getting wider as it's going away. Put in the next one, and let's see what happens there. Flips upside down. So the rule for that is a vertical reflection. It was up here, now it's down here, so it vertically reflected or reflected over the x-axis, but so that basically takes care of all the different types of transformations, shifts, vertical and horizontal, compressions and stretches. We're just talking about vertical. There are horizontal, but you'll deal more with that in Algebra 2. And then reflections. Do we have questions on any of those before we do some mixed ones? So for these next ones, the goal is to try to get away from using the calculator. You can still use it by all means. So you can still graph it and look at what happened like that, or try to look at your rules from the previous examples and see if you can figure out what happened for this one. So what changed if we're comparing it to the original? What happened? It's going to move left, but not down, because there's nothing outside. So left 1. And you can put them in order. If you not put them in order, it doesn't matter. So let's write that rule. What would that be as the rule? Right. There's one more thing that happens. Okay. It does flip. So that would be what? What type of transformation? Vertical reflection. Let's go to the next one. You can either graph that or look at your previous examples, see if you can figure out what changed, what the rules are. It did move down, but not by 3. But by 2. So I'll write that one. And then it didn't move left. It did do something with this 3 though. It did get narrower. Yes. So for the move down 2, how would we write that rule? Vertical shift down 2. And then if it got narrower, what did it do? What happened to it? Yes. But not by 2, by how much time do we have? 41. We can start this one. We may not have time to finish it before lunch, but you can either graph this one or look at your previous examples, see if you can find the change, find the rules. See if we can get at least one before lunch. Let's see, one thing that happens. It does get wider, yes. So then we'll write down the rest when we come back to lunch. Okay. Keep looking for the other ways this changed. We said that it was wider. What else changed? What else happened?
It moved over to the right.
It did do that. Can't move to the right and left at the same time. So it did do something with the 1.
Oh, it moved up.
So yes, it moved up, and then Wilson said it also flipped. Okay, so let's write the rules for all those. If it got wider, what is that rule? Compression by a factor of what? Or by what? By how much? Which one tells us it was vertically compressed?
Because it's wider.
Okay, so because it got wider, which number tells us that, or which information tells us that? Is it the negative? That makes it the compression? The negative? How would we write that rule?
Shift right 3.
Shift right 3. The moved up one. How would we write that one? Not horizontal. Vertical. Shift what direction?
Move up.
Up. And then if it flipped, what is that rule? What questions do we have so far? Once you have written all those down, we're going to do the same thing but with a different function on the back. So just like our parent function quadratic, we're going to graph this first. So in your calculator, go into your y equals, and to get your absolute values, or those signs, go into alpha window, and then go into ABS. So alpha window, ABS, and then put your x in between. Alpha window, and then ABS is the one you're doing, and then put x in between. And let's go to the table, look at the values. What's nice about this function is that it works just like the quadratic. You'll find y values that repeat until you find the middle. So 0, 0 would be one of our points. And we have -1, +1, -1, 1, +1, 1, -2, 2, and +2, 2. And from this pattern, and you can see it, it's going to keep going in both directions. So -3, 3, +3, 3, -4, 4, +4, 4, -5, 5, +5, 5, -6, 6, +6, 6. So this would be our parent function. If nothing happens to it, if nothing changes, this would be our absolute value function. Parent function. What's nice about our transformations is that we really already know what they look like, what they do. That part doesn't change between different functions. Just the function itself changes. So you can either put this into your calculator by adding 2 to the end and y equals, or looking at your previous notes to see what happened, but it's going to be the same as what we just did. So what changed for this one? Moved up to. What would that rule be?
Vertical shift up.
Vertical shift up to. So then the next one would be move down to. And that rule would be vertical shift down to. Then for the next one, if you want to graph that, you could see what happens, or if you want to compare it to your previous notes. What would this one do? Move left 2. And what would that rule be?
Horizontal shift left.
Horizontal shift, left 2. What would the next one be? Move right 2. And that rule would be? Horizontal shift right 2. The next one, you can graph it if you need to see it, or you can look at your notes from the last page. What would this one do? Skinnier, narrower, yep. So if it's getting narrower, what is that rule? Vertical stretch by how much? The next one. Wider. And what would that rule be? Vertical compression by not 2. 1/2. 1/2. And then the next one, you can graph it or look back at your notes from the previous page. What happened for that one? Someone's music is really loud. So yeah. So what would this one do? Flip upside down. So how would we write that rule? Vertical reflection. I'm going to graph because we haven't seen one like this. You could probably guess what it is, but I'm going to show you. So I'm going to graph the original and then graph that one so you can see what it does. So you should be able to see that there are two different colors like graphed on top of each other. The blue is the original, the red is the one that has the negative on the inside. So what it did was it took it and it flipped it over the y-axis. But you can't really see that happened because it looks the same. So we can say the change is really nothing changed. But what it actually did was a horizontal reflection. So usually you won't really see horizontal reflections, like be able to see it unless it moved left or right. And we'll do one like that so you see what happens. For this next one, you can either graph it or compare your notes. What changed in that one? There are two things. That's one of them. It didn't move left. Yeah, what about that 0.25? What did that do?
Add it to the shape of the.
Yeah, it got wider.
Oh.
So this would be like the 1/2. If we change it to the 1/4, it would do the same thing. So then how would we write those two rules?
Compression, vertical compression.
Vertical compression for the second one.
And vertical shift up
Up by 5. Vertical shift up 5. So the vertical compression you can put by 0.25 or 1/4, doesn't matter. For the next one, graph that or look at your notes, compare what happened, what changed. Flip and move right, yes. So then how would we write those two rules? If it flipped and moved right 7. What would those rules be? Vertical reflection, yep. And the other one, move right 7. Oh, I definitely did that in the wrong color, but that's okay. Horizontal shift, right 7. Last one on this table. Look at your graph or look at your notes and see what changed, see what happened. Mm-hmm. So give me one of those 3 things. Say that one more time. It moved.
It moved left.
Left, yes. Okay. Move left to. What are the other 2 things that happen?
Here.
You got skinnier, narrower, yes. And then one last thing.
Move down.
Not horizontal reflection. So horizontal reflection is only if the negative is on the inside, right in front of the X. But it did move down 1. Right, so then how would we write those 3 rules? Horizontal shift left 2. Narrower. How would you write that one or write that rule? Emma? Stretch by what? Not by 2, that's the move left, or, yeah, horizontal shift left. Something that's being multiplied. What number is being multiplied? It is 5. Right, and then our last one, move down 1. How would we write that rule? Shift down. For these last ones, I'm going to show you both of these things because I want you to see what happened and kind of see it all at the same time. So they tell us we're starting with the parent function, the original, and then it's moving 2 units to the right. Then they add in a transformation. So I'm going to graph all 3 of these things so you can see what those 3 would look like. So we have the original. And then it moves to the right. And then there's a negative that goes out of this. So the blue is the original, the red is when it moved to the right, and the black is it moved to the right and flipped upside down. So it did both of those things. So we can fill that in, and then I'll show you what happens to the next one. So we knew already that it moved to the right. And then the negative on the outside made it flip. So that would be your horizontal shift right 2. And your vertical reflection. Now in the graph, I'm going to have these two stay there, but then change that last one to this one, and we'll see what happens. So if you still need to write that down, I'll come back to it. Now the negative is being moved to the inside. So the blue is the original, the red moved to the right, the black, when we put it in, had a negative, but what does it really look like happen? If we're comparing it to the blue. If you didn't know what equation we put in there, what does it look like happen if I'm comparing it to this one?
Move to the right.
Yeah, it looks like it just moved to the right. So what happened was, you put in the original, it moved to the right. From the right, it reflected to the left. So it's always going to look like it just moved instead of actually reflected. So it's a weird hypofunction. So I'm going to do two things. I'm going to write what it actually did, and then I'm going to write what it looked like it did. So this one with the star is the one it looked like, but not what it actually did. Left is what that was supposed to be, not right. Is it actually? But it did actually move to the right too, and then have a horizontal reflection. So how you write that is up to you. Flipped over the y-axis, horizontally flipped, flipped from left to right, any of those work. So what it looked like, rule would be your horizontal shift left 2. What it actually did was horizontal shift right 2 and a horizontal reflection. What's also interesting is that you could write this a few different ways. So we could write it as how it looks. And it would be graphed the same. We could also write it as if we factored out the negative. And they would all look the same. So if you graph them all, they would all graph on top of each other. It's weird. So horizontal reflections, really you'll just need to know when you see it, that's what it is. What questions do we have on any of this so far? There is another page, but we're not going to do that today. We're actually going to do that on Monday. So hold on to these notes so that we can finish them on Monday. There are not Khan Academy quizzes on this lesson. If you want more practice, I know we went through the table. Once we get through the next page, you'll have some practice to do. But if you want to practice any of the stuff we did today, you could do the Delta Math. It's on parent functions, so it'll show you different parent functions and different transformations. You can be working on the Khan Academy that's due next week. Take your notes out from last class, make sure those are done. If you haven't finished your test, now would be a good time to do so. If you wanted to do retake work, now would also be a good time to do so. So use this time wisely.